Hello, morning. Hi, Herman. Can you hear me?
Hello, Xinyun. Hello,
All right.
Wenhao.
Good. Wen Hao, can you hear us?
Okay.
Okay. All right. Great. So thanks. So thanks everyone, and I think Victory is joining as well. Can Victory hear us?
Hi, good morning, everyone.
Good morning.
I can
Good
hear you.
morning. Yes. All right.
Can you hear me?
So yeah. So Victory, would you like to just go ahead and start?
Okay.
Yeah, thanks.
Hi, Wenhao.
Hello.
I don't know if you got my message on Slack yesterday. I think I sent it a bit late though. But basically it had the prototype link where you can sort of see the flow of the vast app, or the idea of what we're thinking of as to what the screen should be. But I sent it to you on Slack, in like the chat. You can check it out when you get a chance. But I don't know if Wenhao wants to start with updates from last Friday.
Okay. I'm working on the Firebase prototype, and right now, if a new user access the prototype, the program, it will automatically add a user record in the file store. And right now, I'm working on list the users on the friend list page.
Okay.
Okay.
So is there something you can share with us on screen too?
The page look like the same because it's a backend job.
Okay. Okay.
It's fine. I think that was the key. I remember there was something about removing some stuff from the sign-in page. I don't know if you were able to do that.
Oh yeah, I have removed the configurations about OAuth 2.0 is about the Google login. We don't need the configurations because we need to config it in the code, not in the page. So I have.
Oh, okay.
Yeah.
Okay. Oh, interesting. Okay. Could you just share the link again if you get a chance? Because I think you migrated the previous link to a new to the new account. On the Slack channel.
On the new project, you need the link of new project, the new website.
Okay. So this is the link I remember that previously.
So,
but because you migrated, yeah.
okay.
If you don't mind sharing
I
the
will,
link.
I will share the new link, and I also need to need this this Firebase project be upgrade to Blaze plan because the functions. If I use the functions as a backend, and Firebase functions need the Blaze plan.
Did you, sorry, Wenhao, I missed that. Did you say this needs to be upgraded to a paid plan?
Yeah, it need to be upgraded to paid plan, but it's paid as you we use Blaze plan for enable functions, but we don't really be charged because it's right now it's prototyping.
So if I'm just to confirm, I'm guessing that's the map function, right? The Google Map function for location data.
No. The Firebase cloud functions.
Okay. I think, yeah, I think I know what you're talking about. With Google, they sometimes want your card, your credit card, before you can use some of their services, even though they might not necessarily charge, but sometimes they need like a card.
Oh, okay, I'll sort that out today.
Okay. Oh, thank you, sir. All right. Thanks for that, Wenhao. With regards to the oh yes, Alida sent me a message yesterday and she was asking if I was available on Wednesday. That's tomorrow. I'm just waiting for her to confirm the time, but I think we're gonna have a session tomorrow.
Okay, cool.
I've sent prototype link, and I guess the next step is I was trying to play around with the process flow for the Vorocast. What's the word now for the forwarding model? And this is a bit tricky, so please just forgive the there's a bit of, it's a bit clumsy at the moment, but I'm just trying to I'm sort of trying to create them like like in parallel and not necessarily in series, if that makes sense. So from the source, so in this case, I'm taking, maybe let's take a case study here where we are saying, you have the source and then you're trying to get it to the destination. So the first step, what I'm thinking of is, the first step is the source is making the request to find out who the neighbors are. And the neighbor discovery, I called it neighbor discovery, request. And then this is my ID, even though I don't think that's necessary. Yeah, I think that's fine. So get my neighbor list. So you're basically creating like a socket connection, and the response, you should get a list of node IDs and addresses and that. I'm guessing we want this to be in a dictionary or something like that. And I will explain that shortly why. And then the idea is we want to identify who the closest neighbor is from the response. So I want to check the AOI from all the neighbors that I just received. But from what I gather, it sounds like this is something the Von layer already does, but I'll confirm that after. I just want to explain what I try to do. So I want to get the AOI, and I want to scan through that list and see, okay, which one is the shortest from the XY coordinate. And once I've discovered what that is, I'm going to create a request. I'm going to, call this request a parent request to the closest neighbor. So what I say parent request, the idea is I want the shortest neighbor, the neighbor I received to be the parent or the father of some sort. And I make a P query, which is the parent query. And the idea is I want to know who you are, and I want to know who your neighbors are. All right, and this is the request I'm making. This is my identity or my ID, and this is my address. This is I want to know. So I've not integrated this yet with the current matcher, because at the end of the day, this matcher is going to be using this model. So for example, I think in the future, something like, matcher request is going to come in front of that, but I'm just trying to make it as independent as possible. So if the neighbor discovery request is received, so as a node in the network, if I receive a neighbor discovery request, I'm basically sending all my neighbors, all the neighbors I find around me, which usually I think is a max of 6 based on how the Von layer is constructed. If a child set is received, this child set request. So the idea is, once I've made this parent request, right, then all the other neighbors make a child request. Now, if you look at this, there's something called child node status here. And the goal of the node status is basically to have a dictionary that stores the current state. So the default state at any given time is that the parent is false and the child is false. In terms of, am I the father or am I the child of the node? So if I've made you a parent, you can not have true. You can either, so if the parent is true, then the child has to be false, and if the child is false, the parent has to be true. But at any given state, the state is false or will always be false. So the idea is, if the child set is received, which is set the child to true, right? So the idea is, we want the neighbor, or should I say we want the parent, which maybe in this case it's probably M3. So we want to tell this that, okay, make M3 the parent and make M2 and M1 the child, right? So that's because so the idea is, there's a source. That's the first step. There's a source, and then there's the request it makes. And then once this is made parent, if there's no match found here, do almost the same process in terms of identifying what the source is, make this the source, perform a neighbor query to find out who my neighbors are. So in this case now, once you receive that P query, or once you send that P query, forward it as a parent, we're basically saying that, okay, set node status to be true and set child to be false. So I'm basically saying this is what parent node is the parent, is the parent, and I'm not a child, so you can forward request, right? And then I want to get the neighbor list. So the idea is I'm basically performing almost the same thing, which I think, not that I think, I know the Von layer already does. I just need to figure out the precise nature of how that works. But I'm performing basically almost the same thing here. I want to know who my neighbors are, and this is who I am, right? So when I perform that check, I want to first be sure that, I want to basically first get the response. So once I make a request like that, I'm going to get the next node and the next node's neighbors or children. If I don't know if that makes sense. I know I'm spinning around a little bit, but let me see if I can try to illustrate this. I'm just going to put that there. Just ignore the numbers. So say the request was gotten, sent to M3. Now M3, the step, M3 is supposed to check for neighbors, like who are my neighbors, right? And who are my neighbors' neighbors? And the idea is, okay, who is M2? Say I have M2, or this M rather, let me just call it X. X is my neighbor, and M2 is a neighbor of my neighbor, which is, let's call it Y. And the idea in this case is, I want to receive the parent node, the coordinates. So the idea is parent node, again, this, I need to confirm that, and maybe I'll confirm that today. But in theory, the Von layer already has this information as to who the closest is, or who the fastest route to get to the destination. It sort of knows who the closest neighbor is. And the idea is, this is who I am. This is the neighbor I requested for. And these are the children of that neighbor, right? So if you notice, I call it PN, which is parent node N, which N is the number. So if it's node 1, it shows the node 1 and its children. If it's node 2, it shows node 2 and its children, and and it continues. And then the idea is, from this received response, I want to identify who the closest neighbor is. And in this case, let's say, in this case, I have my closest neighbor, let's say for the sake of argument, it's X, right? So I want to check X, right? I want to make sure that, I want to first make sure that X is not a child node, right? It has not been set as a child node by maybe S or one of these, nodes. And if it's not set as a child node, then you can forward. But if it's set as a child node, then what did I ask you to do? If closest neighbor, sorry. If the child is true, right, do nothing else, repeat the P query sequence. That's, again, the P query sequence is this, where is, now you set the child, you set the node status, you perform the neighbor discovery request until a match is found. So in this case, if you notice, I did it such that, which, again, this match is found, remember, it's sort of integrated with the requests we're making here. So it's a bit of a generic term, but the idea is, if the match is found, just establish a connection, and with the originating node, which was from here, right, which is the P query, the request itself, where the request was coming from. And again, this request, it's sort of determined by what the spatial request was from the matcher. So whether it was a spatial subscribe or unsubscribe, that data is sort of what passes into that. But the only difference is, the key term here is, we're trying to query for the parents and the children, and we're trying to identify that, okay, once a parent has been identified, make sure you set every other the neighbors around it as children, so that when the forwarding is done, it doesn't make a child a parent, if that makes sense, right? It just goes to the next one, finds the shortest one, and then makes sure that, you know, the basically it keeps going forward, if that makes, yeah, forwarding. It keeps going forward while not repeating the same process on nodes that have been set as children. Now, I don't know if it makes sense. I know it's a bit generic and there's a bit of cleanup from the thing is I'm sort of writing stuff in notes and
Okay,
on my
okay,
whiteboard.
all right. Okay, thanks,
Yeah,
Victoria. I think you put a lot of thought and work into this, which is great. I think some clarifying question. So
Okay.
what's the difference of a parent and a child in what you had just described? Why do we want to distinguish between parent and child?
The reason why I want to the idea is the parent is the closest, right? Or should I say, I don't know,
Closest to what? Closest
to the originating request node,
okay, so to the source node.
to the
all
source
right.
node, yeah. So
Okay,
so for example, if we are saying from S to D, when request 1 is made from S, M3 becomes the, you know, the parent, and M2 and M1 becomes the children. When
okay.
this request checks, does the overlap check, and it says that, you know, there's no match, it simply just looks for a new parent. So
Okay, all right.
it's almost
okay,
like it
all right.
repeats the forwarding.
Okay, all right. Can I also clarify, I mean, this procedure, are you just trying to send from S to D a message?
Yeah.
Is that what you're trying to accomplish, or to
Yes.
locate D? Is that what you're trying to do?
I think it's a bit of both. That's not the question I've really asked. It's a bit of both. The idea was, I have this Von layer, maybe this would try to explain it. I have this source node, and that's maybe S. And this source node is trying to get a message to, you know, somewhere, a node that's in the Von network.
Okay, okay. So it's a
Right.
point-to-point communication, and
Yes.
maybe like locating another node, right?
Yeah, yeah.
Okay, all right. So, well, my feedback is actually I think it can be done really simply. Okay. Because if you just want to locate another node, you know, at another location, it can be done simply by what's called a greedy forward. Okay.
Okay.
And for greedy forwarding, it's literally just, you know, find out your neighbors. Okay, pick the neighbor that is closest to the destination and forward it to that neighbor and repeat. And you will reach the destination, and that's it. You see?
So just to confirm, but does that account for repetitive requests?
No, there's no repetitive requests. You will have just a single line of forwarding this way. The reason is at each node that's forwarded, you are always asking, you know, like, what's the neighbor that's closest to the destination? You see? So there can be only one routing path.
Yeah.
Okay, and that is greedy forward. I think what you're, you know, I can sense that the procedures you describe actually is to do an area broadcast. Okay, it's actually doing an area publication or area subscription, where the goal is not to just reach one destination node, but actually to reach, you know, if you're talking about Vorocast, like what Vorocast is trying to do is it's trying to basically send a message to all the nodes within an area. Okay, that's a circular area, you see, without redundancy, which is different from if I were to just to forward a message to a particular node in a location. You see?
Okay.
I mean, these are two different things. actually.
I see what you mean.
Okay. One is to basically send a message to a particular node that is at a particular location. So there's only a one sender, one source, and one receiver, one destination. But in the other case, I was talking about the Vorocast. Vorocast is, okay, I have a source node, but I want to basically do an area publication, a spatial publication to, to an radius, right? That could be centered
Yeah.
around me, a certain radius. And I want all the nodes to receive that message.
Okay.
See, that is when the Vorocast protocol comes to play, because you can think of this as the most basic way, but also the most wasteful way, is just forward to all my neighbors and have my neighbors also continue to forward out, right? Until it reach the boundary of the intended area publication, right?
Okay. Yeah.
But why the Vorocast has this way of building a spanning tree is that so that each node only receive a forwarded message just once, and that's
Yeah.
the parent children all that comes into play.
Okay.
Okay, and even so, and even if that's the case, I think the process is also it can be much simplified. In the sense that seems like you were trying to determine like a global flag for whether a node is a parent or a children, right? Kind of
Yeah.
like a global state. However, I think it should be noted that the decision is always local. It's always very local, in the sense that you can simply forward to you basically decide whether a node you should forward it to. If it's the closest node, that is, sorry. I guess let's say I want to forward to some of my neighbors. I will check if I am the parent in this case, or I am the closest node to the source among all the other neighbors. And if that's the case, I will forward. Remember that? I mean, that's kind of the criteria in the Vorocast forwarding.
Yeah.
So that's the
Okay.
sorry to jump in here, Shinyan. So
Yeah.
that's the scenario when you want to only deliver once. So you have a message and you want to
Exactly,
make
but to
certain
an
that-
area,
Yeah.
to all the nodes
Yeah.
within an area.
Cool.
So Victor, if you can open the Vorocast paper, I mean,
Yeah.
the paper,
No.
yeah, just share the paper. Because I think Wenhao is also listening this maybe the first time, right?
Okay.
Yeah, just zoom in on the diagram on the right. Yeah, on the bottom left. Yeah. I mean, if you look at this diagram, this is trying to reach all the nodes. Okay, note that it's not just to a single destination. It's actually trying to reach all the nodes within an area, but in an efficient way, so that there's no redundancy. Okay, so the bolder forwarding message arrows, the larger arrows, are the actual path. Okay, while the smaller arrows are the potential paths that was in consideration, but not taken. You see?
Okay. Yeah.
Okay, so this is useful when you're trying to publish to an area or to subscribe for an area. Okay, these are all useful, mechanism. And in fact, I can also feedback that there's no need to query. Okay.
So
The reason is that your immediate neighbors, or it's called enclosing neighbors in advanced terminology. Okay, the immediate enclosing neighbors, you should know them already. Okay.
there's already like a real-time update.
That is, yes, you can take that as a given. Okay, in a VAL network, in a VLN, basically you can take that as a given. That every node knows about their enclosing neighbors.
Okay.
Okay, so there's no query that's actually needed. There's no back and forth that's needed. And you can simply base on your enclosing neighbors information and try to decide like which one of your enclosing neighbors should you forward the message to using
Okay.
the rule I just talked about. Okay, which
Okay.
is asking the question, am I the closest node to the source than any other neighbor?
Hmm.
Okay,
I think
does that make sense?
I'm beginning to see a key difference now. So Vorocast is more like like an area sort of publication, basically
is.
area based forwarding.
Yes, it's called a cast for a reason. It's a kind of broadcast,
Okay.
It's indiscriminate. It's indiscriminate sending. Although we try to make it efficient,
Okay.
right?
So
But what you were trying to do, the scenario, was actually trying to locate and forward to a particular
a
location.
specific node. Yes.
Yes,
Okay. Now I
and
see.
actually
Point to
greedy forwarding is enough, and it's not that, not that difficult or hard. You
Okay.
can simply choose the next node that's closest to the destination location and forward. Okay.
Okay, I see what. So I mean, I'm looking at this now, and I can sort of see, there's this area or this circle AOI that
Mhm.
this node S is sort of forwarding messages to, but in our case, it's probably doing a publication request to node subscribe to that area.
Mhm.
So in our case, we are looking at multiple like how do I put it? We're looking at multiple Voronoi partitions, right? How do we
Well,
forward?
not necessarily. It could be just one.
No, when I say
Um,
not Voronoi, I meant the AOI, the radius.
Oh, okay.
Multiple radiuses distributed across
Right.
a
I
large.
mean, for every publication or subscription, it could be a different radius. Yes.
Okay. Okay.
Okay,
So
but
when
it
the
all
publish
happens on the same, same VAL network.
same, yeah. So okay. So it's almost like when there's a publication request made, there's a Vorocast sequence that occurs.
Exactly.
Okay.
Yes.
Okay. So I didn't think of the area part actually. I was only thinking of the point to point. It makes sense. Okay.
Right.
Makes sense.
But point to point should be much, much simpler.
Yeah. Okay.
Yeah.
Okay.
Okay. All right. So I guess that's a feedback. And yeah. So any feedback from Herman?
Yeah, so I think that doing the point-to-point first, or sorting the protocol or the procedure for that out first, is a good idea. And then once that's working, using this for the area publication. I did actually have a look, after Shunyun mentioned MQTT and perhaps, basically using that API as a basis for the spatial PubSub protocol. I also had a look at MQTT, and I do think there is I think the idea has merit. But
nice.
I don't think,
nice.
yeah. So perhaps that's something we can discuss tomorrow. But I also spoke to Alida as well, and she said she might be able to join the meetings on Wednesdays and Thursdays. So
Nice.
I will
That would be
send her a
great.
message and ask her just to see if she can join tomorrow morning's meeting.
Okay, sure.
But
Excellent.
yeah, cool.
All right. So Victoria, you'd like to assign today's task?
Yes.
Just to
Please.
confirm. Yep. Quickly.
Sorry. Should have forgot about that. All right. So basically today for me, I think it's clear. Vertical, that will be fine. I think I've sent that. Basically the Vorocast 2.0 for area Point. So point to point, I mean, we can simply just use a greedy forwarding then for that, right?
Yes, yes.
Point. And area. Or spatial forwarding, rather. Maybe we should have called it that. Spatial forwarding. And with Wenhao, and from what I gather, I don't know if you said you've not, there's still this to do, right? The click to chat with friend. Is that right, Wenhao? Not sure. Okay. I'm not sure if Wenhao is still there.
Well, how can you confirm? I mean, can you hear us? Hello? I think he's not
Maybe-
muted.
Yeah.
Mhm.
Okay, to share with friend feature.
Okay. So the click to chat with friend feature,
Or
I'm not sure if you've done that, but I know you
have
said.
removed. I have removed the
Oh,
library.
okay.
But
Okay.
when I'm working on listing friends on the friend list page.
Okay. Okay. Yeah, click to chat with friend feature, and also to share link to new that should be blue. Okay. I can just all right. Professor Harriman said he's gonna speak to our leader, right?
I've already done that.
Oh, okay.
But I
That's
can
fine.
give feedback about that tomorrow. But I have to update the Firebase app to make it a paid program, paid
Oh.
billing.
Okay. So I don't know if you have to upgrade it to pay. Just confirm that. I think they just want you to put in your credit card. Most times when you create a Google account, they give you like a $200 or $300 credit, but it doesn't apply
I'll check
until
that.
you put. Yeah.
I'll check that, but I looked at it briefly now, and it does look like certain functions are only available if you upgrade. I mean, so it will be free if your usage is within certain limits.
Exactly.
Yeah,
Which,
but that's fine. I'll have a look at that.
all right. Yeah, I think that's more or less it. I don't know if I missed anything. It should be 3.
Okay, great. So I think you have to remove Herman's second item. There's just one item for him.
Oh, sorry.
All right.
Maybe
All right.
later.
So I think that looks good. That looks great.
Yeah.
Okay. All right. So let's sync tomorrow then. Right.
All right.
Okay. All right. So
Thanks,
Cool.
everyone.
Thanks.
Victor, and Hao, and
Bye.
Herman. Bye-bye. Bye-bye. Take care.